All right, guys, so I'm going to show you how to divide using synthetic division. And synthetic division is great to use when you are dividing a polynomial by a linear term, a linear expression. It's great to use synthetic division. It's really easy because we can divide without using the actual variables, which I'm going to show you how to do that. So the first thing we want to do is we're going to take this divisor here, we're going to set it equal to 0 and solve it. So that's going to be x is equal to 2. So that is what we're going to actually use as a divisor. And what we're going to do is make this upside down division. You know how you used to call it the division house. We're going to do an upside down house. And what we're going to do are use all of the coefficients of this polynomial. Now, if there is a degree missing, we're going to have to replace that with a 0 as a placeholder. In this case, we don't because we have a 3, 2, a 1, and then a constant term, so we don't have to worry about it. So this coefficient is 1, and then we got a positive 2, minus 6, and minus 9. So this is what we're going to do. We're going to drop down the first term here, which is 1. Then we are going to multiply this number 2 by the 1, and that is going to go here. So 2 times 1 is 2. Then we are going to add down here. So 2 plus 2 gives us 4. Then we're going to repeat the whole process again. So 2 times 4 is 8, and that is going to go here. And then we're going to add that down. So negative 6 plus 8 is 2. Repeat the process again. So 2 times 2 is 4, which goes here. And then we're going to add down, and this gives us negative 5. This last number is the remainder. So this is your R. All right, so how does that help us? Because all you have is a bunch of numbers, and we started off with a polynomial and dividing it by some linear expression. Well, this now, if you agree, if I take something to the third power right here, if I take something to the third power and divide it by the first power, doesn't that knock it down to an x squared? And that's exactly what we have. So we're going to use these coefficients to rewrite our answer, starting with x squared because we divided to the third power by the first power. So this would be 1x squared plus 4x plus 2, and then our remainder, so minus 5 over our divisor. Now, of course, I don't need this 1 here. I could just say x squared, but I was just making sure you saw the connection from here to here. So this is our answer. If we take this polynomial divided by x minus 2, this is what we get as our answer. And again, the minus 5 over x minus 2 is the actual remainder. All right, let's look at another one. So let's say we want to divide x to the third minus 3x squared minus 7x plus 6 by x plus 2. So this time, we're going to take x plus 2, set it equal to 0, and that's going to give us negative 2. So we do our upside down house with the negative 2 on the outside. We're going to use all of our coefficients. And there's nothing in the constant term here. There's nothing missing. So we got a 1, minus 3, minus 7, and a 6. Drop down the first one, multiply. That goes here, which is negative 2. Add down. That gives us negative 5. Multiply. That gives us positive 10, because you got a negative 2 times a negative 5. And then add down, which is 3. And then we're going to multiply. That goes here, which is minus 6. And then the remainder is 0. The remainder is 0. So what does that tell us? That this divides evenly. X plus 2 divides into this polynomial evenly. So our answer would be x squared minus 5x plus 3. Remember, we just used these coefficients less 1 degree from the 3. Remember, we started off with a to the third power. So now we drop it down by 1. So this is the answer when you divide this polynomial by x plus 2. And again, this is the remainder is 0, so it divides evenly. All right, let's look at the last one here. So let's say we want to divide x to the fourth minus 6x to the third minus 40x plus 3 by x minus 7. So again, we're going to take the x minus 7, set it equal to 0. So we get x equals 7. So we're going to use our upside down division house. So we have 7. For some reason, I can't write a 7 today. Now, we're going to use all of the coefficients, right? So we got the 1 here, the -6, but look what we're missing. We're missing an x squared term. We don't have that here. So we're going to need to use a 0 for that. And then we have the x and then the 3. You got to put in a placeholder. So we're going to do 1 minus 6. Remember, we don't have an x squared, so we're going to put in a 0, then -40, and then the 3. So we drop this down, get 1, multiply, 7, add, multiply, add, multiply, add, and then multiply. So that's 63, which then gives us 66 as the remainder. So we're down 1 less degree. We started with to the fourth, so we're going to go down to the third. So this would be 1x to the third plus x squared plus 7x plus 9 plus 66 over our divisor x minus 7. And that is the final answer. All right, so that takes care of synthetic division, and next time I will show you how to use synthetic division to help you find zeros of a polynomial. All right.